Hey guys, hello everyone, welcome to this module 2 of Advanced Java Programming. So in this module, we will be discussing in detail about generics, okay? So what is a generics? Generics in Java mainly help you to create classes, interfaces and methods that operate on various types while providing compile time safety. Okay, this will help you to define a class, interface or method with type parameters which can be used with different type in type safety manner. That means it is basically used to create your class, interfaces and methods which will operate on various types, and also it ensures compiler and type safety. Now what are the key concepts? Let's see. First is the parameterized types. Next we have is type safety. Third one is code reusability. Let's see about parameterized types. Parameterized types, generics will allow you to specify types as parameters, which means that you can create a class or a method that works with any type of data but still maintains the type safety. Okay, next is type safety. Before generics, you can create generalized classes or methods using object references, but this approach lacked type safety. Generics provide compile time checks and eliminate the need of explicit type casting. Code reusability, that means generics help in writing reusable maintainable code. So what are the key concepts? If we summarize, first is the parameterized types. Parameterized types help you to generics help you to specify the parameters. That means you can create a class or a method that works on any data type, okay, but it will still ensure the type safety. Second is type safety. What is type safety? Now type safety will help you to provide the compile time checks and eliminates the need of all the explicit type casting. Next we have is code reusability. In code reusability, it helps in writing the reusable and maintainable code. Now let's look at into this example. Like generics in Java help you to define classes, interface and methods with type parameters, enabling them to work with different types while maintaining the type safety. Let's study this example code. Generic class gen of t. Like what it is this? It's basically you can say generic class where t is a type parameter. Okay, it will be replaced by a specific type when an instance of gen is created. Next we have is the field declaration. In field declaration, nothing but you can see a t object declares a field of type t. Then we have a constructor. This constructor initializes the field ob with the, we can say, with the object passed as an argument. Then we have, I guess this was visible guys, this is gen t, that is nothing but you can say it initializes the field ob with the object that has been passed. Then get ob is nothing but you have to return the value of the object. Okay, so next move forward. Get ob will return the value of ob. Okay, next is show the type of t. That is nothing but you can say the void show type method. What will do is it prints the runtime class name of the object using the get class method. That means nothing but if we print the runtime class name with this particular method. Next we have is the demo class, that is the gen demo. Again the same thing. What they have done is they have created a generics reference for all integers, gen integer iob. Then you are creating an object and you are assigning each and auto boxing. You are doing auto boxing to it. That is nothing but you are assigning the value, okay, encapsulating the value 88. Then again you show the type of data that is used by the IOB, that is what type of data it has been used. Followed by that we have once you show, then you get the value. Notice that there is no casting of data is needed. That means no explicit type casting we are doing. Next nothing but we are printing the value itself. Okay, and this is the main structure, or you can say the main syntax when you declare a generics in Java. Once done, you create a generics object for the strings. It is gen string rob is equal to new gen of string generics test. Next you show the type of data used by the string strob. Once done, then you just print the value of the string. Okay, now what is the explanation? You can see generic class definition. The class gen of t defines a generic class where t is a placeholder, okay, for a specific type. Now tob mainly declares a member variable of type t. Then we have gen to. This constructor initializes the object ob with the value type of t. Then we have get ob. Get ob returns method returns the object with that of type t. Then we have is the void show type. Void show type is that displays the runtime of object. Okay, next we have is the using generics. What we can do is the same thing again. This they have explained this part, gen string. So integer IOB, what we'll do is it creates a gen object with the integer type as the parameter. Then again you have passed 88 value, nothing but we have auto box the value. Then show the type in the sense we're just showing, like in this case it's an integer. Then again you're getting the object back. We retrieve the value of OB, which is 88, and auto unboxes into an int. Next we have is the gen string ROB. What it will do is creates a gen object with string all type parameter and initializes it with the generic test. Next is show type. Show type is nothing but it displays the type T. In this case we have a string. The same thing, the output they have show type of T is java.lang.integer. Then we have value as 88. Now what are the key points? First key point is nothing but the type parameter. Type parameter T is nothing but the placeholder, right? Act as a placeholder T for the actual type that will be used when an instance of the generic class is created. Next we have is type safety. Type safety provides the compile time safety. You can assign an object of one type to another to a generic class another type without a compile time error. That means in generics mainly helps us to provide a compile time safety where you cannot assign an object of one type of a generic class type to another type without a compile time error. Next is auto boxing and unboxing. Auto boxing and unboxing, what will happen is Java automatically convert primitive data types into its corresponding wrapper classes. Okay, this is nothing but the auto boxing and unboxing, which I have already studied in module 1. Next is generic works only with the reference types. How it works only with reference type? This is because generics are implemented using type erasure, which involves replacing generic types with their bounds or object if no bound is specified. Primitive types like int or char are not reference types and thus cannot be used as type arguments in generics. That means what they're telling is generics can only be implemented as a reference type but not as a primitive type, because generics whatever we are implementing, they are all type erasure. Type erasure in the sense like it involves generic types with their we are replacing all the generic types with their bound values where no object is specified, or object with no bound is specified. Okay, like no bound value is there. That's why primitive types like int or char, they are the primitive data types. It cannot be used as a reference one because they cannot be used as type arguments. Next is, what is the example of the such illegal use? Gen integer int IOB equal to new gen int 53. This is error because normally it is an integer. Integer cannot be used as a reference data type in case of this. Now what can be the legal use? Let's check, because here int you have used, right? So int cannot be used directly. So to handle the primitives, Java provides wrapper classes like integer, character, etc. So in spite of using int, if you use an integer, then it will be treated as a legal. Then gen integer int IOB equal to new integer 53. This is nothing but, you can say, since we have used integer, that is a wrapper class we have used, therefore this will be correct. Next, generic types based on their type arguments. Based on the type arguments in the sense, this means even if two generic types are structurally similar, they are considered different if their type parameters differ. That means it is not necessary that generic types which are structurally similar, they will perform the same, will have the same parameters. No, there can be a situation where generic types are structurally, they look similar, but if you consider the parameters, they both are actually different. Next is example of type safety. Gen integer IOB equal to new generics integer of 88. Then you have string of hello. Now this is actually illegal and will not compile. Why? Because this ensures that operations involving generics are type safe and reducing runtime errors. Now how it is an error, guys? Because here what we have done is, we have taken integer and string both as this one. What is that? Both into its wrapper classes. That's why there will be an error which is generated because we have taken two generic types which are structured. They look much more similar, but if you see if the type of parameters we have passed, one is integer, one as string. So you can see both are not at all similar. So that's why it generates an compile time error. Okay. That's all about this type safety. Moving forward, next we have is how generics improve the type safety. Let's see. Now generics will improve type safety by allowing the compiler to enforce type constraints, thus reducing the need for explicit casting and catching type errors at compile time rather than at runtime. What happens is generics will help you to will allow the compiler to enforce some type constraints. Okay, now what are the type constraints? It will reduce the need of the explicit typecasting what you are doing, and in spite of catching all the errors at runtime rather than at compile time rather than at runtime. Okay, this way it will help you to improve the type safety just by enforcing the type constraints, and also it helped me to reduce the need of explicit typecasting and catching the errors. Next is non-generic equivalent example. What they have done, they just mimic the functionality of the generic class, but they lack type safety. They will just mimic the functionality of the generic class, but it will not have any kind of type safety. Let's see how. Class non-gen object ob can hold any kind of object. Then we are just assigning the object to it. Then again return it back. Also show the type present. Then again one more. Then the main function is there. Non-gen IOB equal to new gen 88 stores an integer. IOB.showType shows the integer type is present, and also this is nothing but the typecasting what we have done. Cast is required to retrieve the particular integer value. Okay. Same time you are printing the value. Next we are taking is, since we have taken a integer, then now we are taking a string. For the string also you are showing the type. Now once it is done, then again you are just typecasting it back again, like you are using the string bracket. Then again strop.getObject is nothing but you are trying to do some kind of typecasting here to convert it back into a string. Now this line whichever we have done of typecasting is actually incorrect and may lead to they can generate some runtime errors. To avoid it will generate some runtime errors. For that we can just do one more conversion, like IOB equal to strop, then v equal to integer IOB.getObject. What it will do is it will cause a runtime class cast expression. That means a form of exception only it will arise if we try to write the code like this. Okay. Next we have is issues in non-generic code. Issues in non-generic code is first is the explicit casting. Explicit casting, what we'll do is you must cast the objects to its appropriate type, which can lead to runtime errors if the cast is incorrect. That means explicit typecasting should be done in such a way and proper type such that if the cast is incorrect, then it may lead to runtime error. At the same time we have type mismatch error. Type mismatch error, the code compiles even if there are type mismatches. Runtime exceptions occur if incorrect casts are made. That means in case of the type mismatch error you might not encounter any of the compile time error, but at the same time when it comes to runtime you may encounter a error. Okay. Now generic equivalent example, this is the code again, gen of t, this is the placeholder. You are making an object, and then again get the object, return the object, then you are just printing the type of t whatever it is, ob.get class name, get method. Okay. Same thing again guys, here again we have put an integer wrapper class, then again it shows the integer type. Similarly here int v is equal to into iob.getObject. Here we are not doing any kind of typecasting or anything. That's why it's mentioned no cast is required. Directly we are printing the value. Same time next what we are doing is, here we have done with the string. Next we'll do with here we have done with integer. Now here we will do with the string. For string again we are passing generic test. For generic test, once you are passing generic test, again you are just using the show type method. Once show type method is done, you are checking if any again we are doing if any casting is required or not. If there now there can be a situation where you get a compile time error if you do this gen string to gen integer method. So if this kind of operation is there, like IOB equal to strIOB, that means you are just comparing or you just equating the integer object with the string object, you might encounter a error stating it's an incompatible data type. Benefits of generics. First benefit is like type safety. Type safety is like errors can occur at compile time, reducing the risk of runtime exception. Next is elimination of cast. Elimination of cast is nothing but making the code cleaner and less error to happen. Next is declaration of generic class with two type parameters. Two type parameters, what it will do is again class 2 gen t comma v2 placeholders I have got. Now t ob1 and v ob2. Next what I am doing is I am just taking a constructor to initialize both the parameters. Now let's see how it happens. Okay, so just we have taken this two placeholders. We are just assigning the object value to it, that is ob1 and ob2. Done. Then what we'll do is we will take a method to show the type of t and v. T and v we have taken. Now it's time to show their type. How will you show the type? System.out.println type of t is ob1.getClass.getName is the type to is the function name to get a particular type of a particular placeholder. Just remember these two names. Then methods to return the value of t and b. For returning the values of t and b, we use t get object ob1 return ob1, v object ob2 return ob2. Now using the generic class with two type parameters. How will you use a generic class with two type parameters? You need to specify both the type parameters when creating an instance. That means when you use two generics, then we have to make sure that we specify both the type parameters when we are creating the instances. Now let's look into this code. Public static void main creating a class called simple gen 2 gen integer comma string. We have seen that two wrapper classes we have taken. This is the object equal to new 2 gen of integer string 88 generics. Okay, this 88 is for integer, this is for string. Okay, now next what we are doing is we are just showing the types. For showing the type, this is the method tg obj equal dot show types. Obtain and show values. Obtain and show values. Once you just show the type of t and v, once you are showing the type of t and v, yes, then you show the values. Showing the values is nothing but in t and v what all values were there. One is 88, one was string. Okay, that means now what is the type now? For type of t is java.lang.integer, type of v is java.lang.string. Whatever the value was present, 88 and generics will be printed. Now what are the key points? Key point is multiple type parameters we have passed. It uses two types of parameters, t and v, which are nothing but the reference types, not the primitive types. Primitives are only int and char. Okay, but now here we have used integer and string. Remember, so whenever we have a primitive data type, we have to convert it into its corresponding wrapper. This allows the class to handle different types of objects. Next we have is constructor and methods. Constructor and methods, what it will do is it will take certain methods like show types, get ob1 and get ob2 to work with the type parameters. Same type arguments, in the sense it is possible for both type of parameters to be at the same type. That means in one line only we can say 2 gen, both the same parameters we are taking. Once two string parameters, we are passing the same thing, the same wrapper as string, passing a and b. Okay, next we have is the benefits of multiple type parameters. Benefits of multiple type parameters is like we have flexibility, type safety and reusability. Flexibility in the sense like it allows creation of more complex and versatile generic classes. We can create much more complex classes also. Type safety it is used for, that means generic classes are consistent and prevents the type mistakes. Also reusability, that means you can reuse the code by allowing the same class to work different types. Next we have is creating an instance. How will you create an instance of a generic class? Here we specify the type argument in angle brackets and provide the constructor arguments as needed. That means we need some angle brackets to specify the type arguments and the provide customer arguments as needed. So let's see. Class name type list var name is equal to new class name type argument list constructor argument. This is the syntax. Remember this. Type argument list, variable name, constructor argument. The type arguments are for the type parameters. The var name is nothing but the variable name. The constructor argument is nothing but the arguments which are passed to the constructor itself. What is bounded type? Bounded type is like sometimes you want to restrict the type that can be used as type parameters. Bounded types helps to achieve this by specifying constraints on the type parameters. That means if I want to restrict a particular type parameter, like I want only string or integer, I can use the bounded type in that case. Next we have is the upper bound. Upper bound, what we will do is you can specify an upper bound for a type parameter to restrict it to a certain class or its subclasses. That means we can, upper bound is mainly used for restricting it to a particular certain class or subclass, which is mainly done using this extends keyword. That means you can see class name, it will extend the properties of superclass or something. Okay, here T can only be a superclass, subclass of superclass or a superclass itself. This ensures that the type parameter T will have all the methods and properties of the superclass, nothing but inheritance itself. Example with numeric types. Let's see this example here. What it happens is we are calculating the average of an array of numbers. The original version of the class fails because T is not constrained, so the compiler does not recognize double value method from the number. Now what happens is here we have just declared one, you can say array of, not array, like a class called stats, which is performing the average of all the array numbers. Like here we have seen double average we have taken, so just double sum equal to 0. We're just calculating all the elements, all the numbers which are present in the array and just calculating its average. Now to resolve this, now you can see sum plus equal to num plus double dot value, we have got an error. Okay, now why error? Because you can see here that because the T value, whatever it is, we have not given any constraint to it. Therefore, compiler is not able to recognize of what particular data type it is. That's why it will generate an error. Now to prevent this error, what I will do is next. Now since class T, we have not used any kind of extents from where it is extended. That's why it was the error, and also we have not declared the type of data. Then to resolve this situation, you can bound T by a number which is the superclass of all the numeric upper classes. That means if we extend this from number, that means if we use a superclass, then this error can be resolved. How? Same thing, the class stats where T is the where T will extend the number nums, then double average sum. You are just calculating the length of the array, and just what you are doing is you are calculating the sum and calculating the average of all the elements in the array itself. Okay, one more example is there. You can see integer num equal to 1 2 3 4 5. Again starts integer iob. Again the same thing, in inums value you are just storing like all the elements of the array in integer wrapper form. Then a double v is only used for getting the average. Now system.out.println, you are printing the average. Okay, done. Then again double dot denums is nothing but, again you are creating an array of double data type. You are sending all the double you can say elements. Then again you are creating one, you can say an object like this, stats and double dob equal to new stats. Then same thing, you are printing the average. Again you are doing for the string also. Okay, now this particular line like double of a, because this double of a make encounter a compile time error, because string is not a subclass of a number, right? Because obviously string is not a subclass of any kind of number. String is itself a collection of characters and everything, so it's not a subclass of any number. Next is multiple bounds. Multiple bounds, what happens is you specify a multiple bound for type parameter. The syntax involves combining the class and the interface. That means you're combining the class both and the interface as well. That means class gen of T, it will extend my class also and will extend the interface as well. Now here T must be a subclass. Now here the T is also a subclass of my class and must implement the my interface. What is my class? My class is a class of type T that I'm extending, and also my interface type T that has to be implemented. What is the summary? We have a generic class syntax here. Okay, then with the instance creation, what we have done, then we have the bounded types. That means we're giving constraints to and restricting the type of parameters. Also we have multiple bounds. Multiple bounds is nothing but we use extents with multiple types to combine class and the interface. Okay, next we have is using wildcard arguments. Now wildcard arguments mainly provides to handle situations where you want to work with types that are unknown or variable. That means when you want to work with certain types which is not known to you, or it's not or it's a variable kind of thing. Okay, so if it is not known, then it is denoted by a question mark, and it allows for more flexible and generic code. Fine. So that means the wildcard arguments will generate some more flexible as well as generic code. Now let's see. So here this is the problem statement. So what happens is you have a stats class that calculates the average of array numbers. You want to add a method same average that compares the average of the current stats object with the another object regardless of the specific numeric type they use. That means what happens is the problem statement says we have a stats class which will calculate all the average of array of numbers. Also we have to create a method called same average, and this method average, what it will do is it will compare the average of the one particular stat object with the another object. Okay, so what is the initial attempt? What we have taken is boolean same average stats ob, then return if the average is equal to the this ob dot average. That means one object you are taking its average, you are comparing with all the other objects average. If it is true, then return true, or else return false. Okay. Next we have is solutions using the wildcards. How to solution using wildcards? To create a more flexible same average method, you can use a wildcard method also. Now what it will do is it will make use of this question mark, represent the unknown type, and allows for greater flexibility. So let's analyze the code. Boolean same average, we have passed a question mark here. In spite of this t, we have passed a question mark only because the value is only not known. Okay, now if the average is equal to ob dot average, return true or else return false. Next we can see that stats, what is this question mark? This represents a stats object which is of the unknown type, and it can be of any type it can be, which will extend the number class. And this average method does nothing but it will compute the average of the numbers in the array and is compatible with the stats parameter because it uses the wildcard. Okay, so let's continue with the generic constructor example. Now next we have a generic constructor. What it will do is it will handle different types of numeric data types, and also it makes the class much more flexible. Okay, the class genCons has a generic constructor which allows it to handle the various numeric types. Now you can see we have a generic constructor here, that is t extends number gen constructor t argument. What it will do is it's nothing but a generic constructor that can accept any type t that extends number like integer, floating, double. Okay, and also inside the constructor we have argument or double value. This is mainly used to convert the number to a double which is stored in the val field. Okay, next is nothing but you are just printing the value. Provided by that, first we are passing the two arguments, whether it is an integer. First is the integer, one as a float. This is 100 and this is 123.5f. And next what you are doing is you're just showing the values. Test1 dot show value, test2 dot show value. The show value method is nothing but it is used to display the value, demonstrating that the constructor correctly converts and stores the numeric values. Okay, same thing again. They have mentioned t extends number gen constructor t argument, then again double argument or double value. Then next is type parameter. Type parameters, t extends number indicates that the constructor is generic and can accept any type that extends the number. Also the constructor logic, that is value equal to argument or double value. It mainly converts the given argument to double and assigns it with the instance variable, that is val. Same thing we have seen in the previous code itself. Then all the classes, that is fields and the methods, we have already known. The show value method prints the value. The field, that is we have used double field, as well as double field is used to store the converted value. Next is the objects creation. Object creation, how we have done: first we have passed as an integer argument, then we have passed a floating argument, then nothing but a test1 is created with the integer value of 100, test2 is created with the float value of 123.5l. Next is the method call. Method call is nothing but once you call the show.val method, this will print the value stored in the val for each generic class object. Value is 100.0, value is 123.3. Now next is generic interface declaration. How to declare interface using generics. Interface min-max t extends compatible t. Now what is this comparable t? This means the type parameter T must implement the comparable T interface, which is used for comparing objects of type T. Okay, next we have is a method. Method is the min-max interface we have used, which mainly uses two methods, min and max, which are expected to return the minimum and the maximum values of the collection. That means I have a collection. This particular min-max method will help me to retrieve the minimum as well as the maximum value of the collection. Also, we have this comparable method. Comparable method is comparable T. What we do is this means that the type parameter T must implement this interface, which is used for comparing the objects. Next is implementation of generic interface. This is the code for that. First, we have this line class my class extends comparable T implements the min max we have used. Then here what it will do is it will give you all the maximum and the minimum values from a given collection or whatever array we have taken. Let's understand this code. This is the code snippet, guys. My class T extends compatible T. This class will implement the min-max T interface and provides the concrete implementations for the min and the max method. That means this will help me to use the min-max T interface and also provide concrete implementation for the min and max methods. Next we have is the constructor. This constructor will help me to initialize the vals array with the given type. Next we have is the min and max method. Min and max method will return the minimum and the maximum values. Next we have is using generic methods and implementation. What we have done is we have taken two arrays, inums and chars, which has all the integer and it has all the character value. Next we are creating the object of integers and character. Then we are just printing the values from the maximum and the minimum element present in the array. Okay, now creating an instances. My class integer, my class character are nothing but instances which are created for the arrays of integer and character wrappers. Then method calls like max and min method we have used to finding the maximum and the minimum element in the array. Output is nothing but the in inums what is the maximum element, what is the minimum element, in characters what is the maximum element, what is the minimum element. Okay, so we have certain key points to remember. First, generic interface. What is the generic interface? The min-max interface uses generics to define the contract finding between the minimum as well as the maximum values. Moving forward, we have the bound on generics. What is this bound on generics? Bound on generics, the type parameter T is always constrained by the comparable T, ensuring that the type used by the interface supports the comparison. Obviously, we are using this comparable T method. That means it should support the comparison. Next is implementing generics. Implementing generics, like using the min-max method, uses the parameter T to work with the different types. Next is type safety. Type safety in the sense it allows implement comparable can be used using min-max method. Then we have is the raw types. What is raw type? Raw type is like when a generic class is used using specific type of without specific type of arguments, it is referred as a raw type. Okay, for example, gen raw equal to new gen of new double 98.6, it creates a raw type of gen object. That means without specific the type of argument only, you are giving the type, you are giving the value. Okay, this is nothing but a raw type. Then compatibility means like raw types are compatible with legacy code that does not use generics. Okay, and they also allow older code to interact with the newer generic code without any modification. That means using these raw types we can interact with the old version of the code as well as the new version of the code without doing any kind of modification. Next is creation of raw type. How will you create a raw type? Gen raw equal to new gen of this raw type we have created. We can see that no type parameter is specified, so gen is treated as gen of object. Okay, this makes the type of OB unknown, therefore potential safety issues. Next we have is the casting issue. Casting issue is nothing but this cast works double D equal to double D raw of get OB. What it will do is the cast works because the raw was originally created with a double, you can see. Then but if the type changes, this can lead to the class cast exception at the runtime. That means if some of the other exception is occurring, then it can change at the time of runtime. Then assignment issues, strOb equal to raw. The compiler will treat it as correct, but potentially it's wrong because it's not safe sometimes. Also raw equal to IOB, same, it's okay, it is treated by the compiler correctly, but sometimes potentially it's wrong, because assigning IOB to raw is allowed, but it's unsafe because the type information is lost. You are not giving the type information of this particular raw type. Okay, next is type safety and warnings. What is first we have is the unchecked warnings. Unchecked warnings are the warnings when used in a way that could lead to type safety issues. So it can mainly lead to the type safety issues, unchecked warnings. Let's see. Gen of raw equal to new gen of new double 98.6. This is the unchecked warning. Now here you can see raw equal to IOB. Now here it is okay, but potentially it's wrong, but no warning is issued for this line because the assignment does not introduce any type safety beyond those which are already present. That means raw equal to IOB, the compiler is not going to generate any kind of warnings in this case, because it does not, this assignment operator does not introduce any kind of new type safety which is already present. This is again the code snippet for that. Again, you are just declaring an object of t. You are passing the constructor for reference. Then again, you are returning the object. Next, again, you are creating an gen object of integers. Same for strings, and again a raw type and giving a double value. Okay, this code, guys, you guys have to practice and remember, because syntax is only very much important. Then then sometimes you may get an error if you have a runtime exceptions. We have this situation where int equal to integer raw dot get object. Here you get a runtime error, but sometimes it is it's okay. The compiler will not generate any error, but potentially it's wrong because you don't know the type of the data which is being passed. So it may give you type safety warnings as well. Next is generic class hierarchies. Generic class hierarchies is in the sense, in class hierarchy involving generics, they can act as a superclass also, and its parameters must be passed to the superclass itself. That means all the parameters should be passed to the superclass, sorry, to the subclass from the superclass. Okay, example, let's see. This is the, you can say, the subclass. Where you are just creating an object, you are just creating a constructor, you are creating an object, and you are just returning the object back. Then next what you are doing is you are extending the properties of gen t is nothing but the superclass or the parent class itself. Now let's look up the explanation. Gen of t is a generic class with type parameter t. Gen 2, another more class is there which will extend the properties of gen of t, also the type parameter t to match the superclass. Okay. When you create an instance of gen of 2, the type parameter t specified with gen of 2 is passed to the gen, ensuring the type inconsistency. That means always whenever you are using this hierarchy, that is generic class hierarchies, you have to make sure that yes, type consistency is there. Now gen 2 integer num equal to new gen 2 of 1000. In this case, integer is passed as a type parameter. Then so ob in gen will be of type integer. Same thing, same guys. Again, one code we have implemented. Again, gen t is a generic class. Then again, one object you have created. Again, you're returning that object back. You are creating a subclass. In the subclass, again, some two objects you have passed, gen o1 and o2. Then again, we have a superclass from where it is inheriting all the properties and again returning the object. Next, what we are doing is just passing. We are creating the string and integer, passing the value as value is 99. This value is nothing for the string. This 99 is nothing but the integer. Once you get the object 1 and object 2, you will get value is 99 itself. Now explanation, gen 2 of t and v extends gen of t, introduce an additional parameter. You can see additional parameter is used. Also, gen 2 can be used as both the type parameters for t and v of its own methods and fields. Now the non-generic superclass with generic subclass. Let's see what is a non-generic superclass now. A non-generic class can be the superclass of a generic subclass. This you have to remember. A non-generic class can be a superclass of generic subclass. So what happens is, again, you are just creating one more, you can say one non-generic class is there. Okay, you are just assigning the value of num equal to I, one constructor you have created. Again, you're returning the value. I guess it's visible. Yes, one constructor you have created, and again you're returning the value. Then again a generic subclass. which is extending the non-generic subclass. Again, superclass you have used super keyword because you are extending all the properties from the superclass itself. You're returning the object, and then once you return the object, you have to create the once you return the object, and again the main function comes where you are again creating a generics line where string you are passing also hello and 47. We get the num value, also the object. That means first we print hello and next we print 47. What is the explanation, guys? Non-gen is a non-generic class with the integer field and method. Gen t extends non-gen and it adds on own parameter. Then gen can use both its generic type t and the non-generic members of the gen. That means the code explanation is only given. Nothing but a non-gen is nothing but a non-generic class. The gen t is nothing but the parent class itself, which will which from where it here. From here the subclass will take all its properties and all its parameters, and it can be, and gen can be used as both generic type t as well as the non-generic members also. Next we have is the using the instance of. Let's see how the instance of will work. The instance of operator works with generic types but with some limitations due to the type erasure, which removes generic type information at runtime. Very much important to remember, that is the instance of operator. What it will do is it will not work sometimes because it has some limitations due to its erasure, which removes the generic type information at the runtime. That means at runtime some of the generic type information is lost. So that's why let's see how to use the instance of operator. Again, same thing, generic class hierarchy you have used. One generic class you have created, creating an object and returning the object. Again, one more, you can say a subclass is created which is extending the properties from this superclass. Then again, class hire demo, what you are doing is again creating a gen object for integers. That means of 88 we have seen, 88 we are passing it. Then again, again one gen object of integers, 99 you are passing. Again a gen object for strings, a string value you are passing. Now you are checking the instances in the sense like whatever instances you have created, like we are comparing it, okay, with this value gen 2. So IOB of 2 is an instance of generics of 2. You are printing that IOB 2 is a instance of gen of 2. Okay, at the same time you are comparing with all the statements and just checking whether which one is the instance of what. So IOB 2 is an instance of gen, STROB 2 is an instance of gen 2, just checking each and every condition. So let's understand the code first. Type checking with the wildcards. Question mark is nothing but the wildcards itself. The IOB2 instance, that is gen 2 of question mark, returns true because IOB2 is indeed an instance of the same form of gen 2. This wildcard question mark signifies that IOB2 could be an instance copy of gen 2 without any type parameter. That is, here we are past this question mark. No, this question mark will is nothing but the you can see a wildcard pattern which signifies that IOB2 can be an instance of gen 2 itself without with any type parameter. Next, it will return true if the gen 2 is a subclass of gen, or it will return false if I'm checking if the if it is true, the gen 2 is a nothing but a subclass of gen, but if it is not a subclass, it will return as false. Next is type checking for different types. STROB2 is an instance of, again the same thing you have done, both will return true if the instance of STROB2 is an instance of generics of 2. Then again it continues. Compile time errors cannot be compiled. The errors which cannot be compiled because generic type information is erased at runtime. Java's type system cannot retain specific generic type parameters unlike integer after compilation. Let's see the casting first. Now casting is nothing but casting in generic classes is subject to same compatibility rules. What is the compatibility rules? Legal, which one is correct, which one is incorrect. This is gen integer of G, again gen integer of IOB2. This is considered as legal, but at the same time if you are using this method gen of long of G2, then gen less than this value, this particular wrapper of IOB2. The cast in gen of integer IOB2, this one is legal because IOB2 is indeed an instance of integer. Okay, but this casting is illegal because IOB2 is not an instance of gen of long. It's specifically an integer itself. That means casting is only specific to integer only, not any kind of long data type. Fine. Now let's look at the summary. Summary in the sense the instance of operator can be used with generics, but you can only check for the existence of generic types using the wildcard. That means using wildcard you can check for the existence of any generics. Then generic type information is always erased at the runtime, so checking against the specific generic parameters is always not possible, okay, because always it's getting erased at runtime, so it's sometimes very difficult to track like where the specific parameters are not available. Next is casting. Casting between generic type requires the cast be consistent about the actual type of the object. Next we have is a type inference with generics. Type inference with generics is nothing but it is represented by the diamond operator, that is this, okay. Diamond operator example, we have two objects we have created, T, V, a generic class T and V, OB1 and OB2. You can see my class. Again you have created additional methods we have before JDK. Creating an instance of my class requires specifying the type arguments twice. So this is my argument for specifying the type, okay. And again one more is that's not that much important, guys, just for the study you just remember this. This is the general form. Next you have is the example of method calls, like how you call the methods of particular generics. Type inference is also useful when passing generic arguments to methods. That means you are just creating a method, okay. We are just comparing whether it's true or false. Two objects are created and two objects we are checking whether both are equal or not, like ob1 equal to o dot ob1, ob2 equal to o dot ob2. If it is true, it's fine, it will perform some operation, or else it's false. Then next we have is erasure. Now, Java generics use type erasure to maintain the compatibility with older versions of Java. This means that the generic type of information is removed during the compilation. Instead of using the generic type parameters, the compiler replaces them with their bound types. Okay, so what happens is in type erasure, it is mainly it maintains the compatibility with the older versions of the Java, and also the generic type information, whatever it is present, it all gets removed during the compilation. So instead of giving the generic type parameters, the compiler, what it will do is it will replace them with the bounded types. Okay, now how the erasure works, let's see. Type parameters are replaced. That means type parameters are replaced by their bounds. Objects are not specific. Objects, if no bounds are specified, then we do a casting. That means compiler inserts cast to ensure the type safety. Also compatibility in the sense that the generic code is compatible with older and generic code. Next we have is the bridge. Next we have is the bridge methods. Bridge method, what it is? To handle the situations where erasure results in mismatch between the overridden subclass, Java compiler generates the bridge methods. Okay, that means when type erasure method can lead to some kind of mismatch, then bridge method is used. They are mainly synthetic methods that mainly bridge the gap between the type erased method signature of superclass and the specific signature of the subclass. That means two signatures, one of superclass, one of subclass. It is mainly used to bridge the gap between them. Okay, same thing again, guys. Generic class of T is there. Again, you create an object, you just return the object back. Next you have is the you can just same thing again, you are extending the properties of from gen main class string super keyword you have used, then again overriding it, again you called it a super get. So what happens is let's look into this example. Gen2, like Gen2 you have seen extends the gen of string, that is nothing but the parent class. The generics of 2 will extend the generics of string and the overrides the get object to return a string. So it will override this method and it will give return a particular string. Due to the type erasure, what happens is the JVM expects the get object method to return an object. To ensure compatibility, the compiler uses the bridge method. Bridge method in the sense java.lang.string object, java.lang.get object. What it will do is it will help me to bridge the gap between the signatures of the parent class as well as the subclass. Next we have is the ambiguity of errors. Ambiguity in the errors is like when working with generics in Java, ambiguity errors can arise due to the type erasure. Due to type erasure, sometimes ambiguity can occur. So these errors occur when the different generic declarations resolve to the same erase type, leading to conflicts in the method of resolution. That means when it's a kind of conflict which is mainly occurring when different generic declarations try to resolve to the same erase data type, leading to a conflicts in the method resolution. Okay, so let's look into the solution, into the program. Again, you have created a generics code. Again, two objects you are creating, you are overloading these two methods, then again you are setting the value. Now in this example, myGen class has two overloaded set methods. We can see two overloaded set methods was there, one taking a parameter of type T, other taking a parameter of type V. Okay, now however, ambiguity issues can arise due to its type erasure. How will the ambiguity occur? First is the type erasure. Like Java's type erasure process converts all the generic type parameters to their bound type or object, if not specified. That means type erasure conflict occurs when the Java only will type erasure will convert all the generic type parameters into their bound type. Okay. Next we have is instance creation. Instance creation, what will happen is, in this case, both the T and the V, whatever you have passed as string, so both the set methods effectively become void set string O, further exacerbating the ambiguity. So what happens is, the instance creation already we have done using the both set and using the set methods. So this way the instance creation is mainly done. Next is attempt to restrict the type of parameters. When we can restrict the type also, even with a restriction like V extends number, we can see ambiguity can still occur if both the type parameters end up using the same bounded type. That means if we are using the same bounded type, sometimes you can get sometimes ambiguity can result. Next, generic restrictions. There are several important restrictions when we use generics in Java. First is they cannot instantiate the type parameters. That means you cannot create an instance of a type parameter. Then for example, this OB equal to new of T is treated illegal. Since T is a placeholder, compiler cannot know what specific object it has to create. Okay, T is a placeholder we have given. So if we are writing as this OB equal to new of T, it is not proper, because compiler comes into a confusing state where it cannot identify, cannot know whether what object specific it has to create. Next is static members restriction. You cannot declare static members using the type parameters like static TOB, static TGetOB. This is all treated as illegal because static members is something we can't declare. Next is generic arrays. Generic arrays, you cannot create an array of generic type parameter. For example, we have taken an array of nums. So passing this value of T equal of size of 10 is treated as illegal, because generic arrays is something which are not possible in this passing this kind of parameter. Okay, then we have generic exception. Generic exception, you cannot create a generic exceptions. This restriction is because exceptions are handled differently in Java and cannot be parameterized. That means this particular generic exception is always handled in different ways in your Java programming language, and it cannot be parameterized. Okay, so guys, that's all about module 2. Module 2 we have covered. If I summarize from the beginning, we can see generics. Okay, followed by generics, we have seen about different kinds of wildcards. Their upper bounded, lower bounded, as well as different types. We have seen different code snippets. Coming back to the important questions and the VTU question papers, yes, I will be uploading a video where I will be covering all the previous year question papers as well as the internal question papers also, which will cover a good questions for this module. And all the notes and everything are prepared from the textbook itself. I repeat, no other resource materials. So please, it's a humble request, please study from these notes and from the textbook itself to score the maximum marks. If you have any doubts or anything, please let me know in the comment section. Till then, like, share and subscribe. Thank you guys.